Hi everyone, my name's JD. I have a YouTube channel called Rainfall Projects, and I'm a farmer out here in Oregon. I do a lot of projects out in my barn in my spare time, where I do metalworking and woodworking. And lately I've been getting a lot into CNC, and I use Aspire and VCarve to do all my design work and all my toolpaths. And I was gonna go down to San Diego and give a presentation at the conference, but fortunately that didn't happen. So I got asked to do a virtual one here. The thought of doing a monologue makes me sweat a little bit and get a little uncomfortable. So I asked Sami to join me. Sami, do you want to introduce yourself and a little bit about what you do?
Sure. I'm Sami from Avid CNC. I manage all of our creative production and media and education tools. I love Vectric products. I've used VCarve for about 5 years now. I used to teach CNC and woodworking classes at a local makerspace, and now I get to do that full-time for my job here at Avid CNC. So I help make our videos and write educational content, and I get the pleasure of getting to work with so many amazing content creators and customers. You know, JD lives about an hour from me. I'm in Portland, Oregon, and I just am so excited that we get to do this conference where anyone, anywhere can come and join. You know, we don't have to go to this physical location, so I feel like that's really a big part of the Avid CNC mission, is to bring accessibility and CNC to everyone everywhere. So thanks, JD, for asking me to help out, and I'm excited to talk all about CNC and making things today.
Yeah, thanks so much for being here. I was looking forward to the San Diego weather though, but that's pretty nice down there. But hopefully next year we can do that, huh?
Let's plan on it.
So I thought what I'd do is go through 3 of my projects I've done that are a little more intensive on the Aspire side, and just kind of work through the steps I went through. And I'm still learning a lot about Aspire. I have a lot to learn. And so if there's any comments you have on other ways I could have done it, just feel free to jump in. And I'm looking forward to learning from the Aspire community as well. If there's anything I'm missing or any ways I could have done it easier, really looking forward to getting some input on this. So I have 3 projects that I chose. One's a giant 60-inch bowl that I made, just kind of for fun, just for the challenge of learning the programming. The second project is a Hurley. Do you know what Hurley is, Sami?
Yeah, this is an Irish game. It's a stick.
I think it's more warfare than a game.
Oh, okay.
but yeah.
Well, what do you use a Hurley for then?
Yeah, you're right. Yeah, it's a brutal sport they play over there where they just beat the crap out of each other, and they use these wooden sticks that have a really cool shape to them and look really unique. And for my father-in-law and my groomsmen, I made customized Hurleys for them. My wife and I got married in Ireland a couple of years ago, so that was the gift I went with. And
yeah,
then
I'm obsessed with this project. I think it's really detailed, 3D engraving, double-sided. You know, it has all of the complexities, but I think the way you approached it, Aspire made it really easy to do, and you worked through a lot of technicalities, but I think it really came out well.
It was the first time I really learned some of the 3D modeling stuff. Had a lot of fun doing it. And then the third project is a sword that I got commissioned to make, and it was a pretty fun project as well. So how about we start with the Hurley? That sound okay to you?
Yeah, let's do it.
Okay. So I just created all these different saves at different points in the project that I can load up. And I thought I'd just kind of walk through the steps I took to come up with the finished project. So I did a bunch of looking on the internet to find a good picture of the Hurley, and this is the one I settled on. 1, because it's high resolution, a nice picture, and 2, the Hurley's turned so it's facing towards the camera and it's not skewed at all. So it's a lot better for tracing around. And 3, he just looks like a badass. And that guy's pretty cool, right? And so what I started doing was I zoomed way in on the Hurley and started tracing around the outside. And when I trace, I don't worry too much about the very first pass. I just kind of quickly click around the Hurley, hitting some of the points. kind of where the curve starts is where I try to put my points, but it's not that critical. And then once you have your very rough shape, I do the node editing tool where I zoom in and click on the individual lines and convert them to Bezier. Is it Bezier or Bezier? How do you say that word?
I say Bezier.
Bezier, that's what I'd say too. And then you can move the points.
I call this node mode.
Node mode, I like that. You're seeing okay what I'm doing here?
Yeah, no, it looks great. I love using photos as a reference, you know, and then you can either trace it like this because it's a very multicolorful image. I think also using the editing for the bitmap tracing is also super helpful. If you have a slightly more high contrast black and white or grayscale, works really well.
Yeah, I couldn't find any Hurleys that were like clip art, whereas black and white that would automatically trace. The only ones I could find were pictures like this where I didn't think the automatic tracing was going to work very well.
Right, yeah.
So I just continually worked around the Hurley until I had my Hurley shape. I'll load the second file. So there's the Hurley shape right there. And I scaled it to the appropriate size. I think they're like 36 inches long, something like that. And then to make this a 3D shape, I switch into the modeling tab. And I want to use the two rails tool up here. But to do that, you have to have you need to have two rails that a shape's going to follow. So I zoom way in on one end. And with the node editing, I add a second point. And then I can delete that little span right there. And then I do the same on the opposite side, where I zoom way in, insert a point, delete that span. And so now I have a top and a bottom piece, and the break is really tiny, like right in the middle. You can hardly even see it. So I got the bottom half and the top half, and then I go into the modeling tab, and I use the two rail sweep, and I select these two halves. And then I need to have some, what are they called? I need to have some cross sections to match the shape of the Hurley. That's going to sweep between the two rails. Right, you need those kind of like
arcs shapes.
I got those right here in a different layer. So the end of the Hurley is a little more round, so it won't slide out of your hands. And then the middle part of the Hurley is slimmer. And then the end is square. The end is usually cut straight around the end. And so those are my three cross sections. So I'll use the bottom and the top rail. And now I can select my cross sections to use. I'll use this one first. And I'll select these beginning nodes. And it's cool because it color coordinates. See the cross section I'm using here has this red point. And then that matches up with this one. And I want the round part to go across the whole handle. So I'll click a little further down. And I can adjust it so it stays perpendicular to the Hurley. And then about there, I want it to start transitioning into the middle cross section. So I'll select the next one and click a little further down. And so now between the red and the yellow, it's going to transition between these two shapes. And I love how that do that. It does it just really smoothly and seamlessly. So it's a pretty cool feature. And so
yeah, that's amazing.
And so then I want this cross section to go the whole length down until about here. And then at that point, I want it to switch to the last one for the bottom part that's square. And so again, this one's green, so you know it corresponds to number 3 here. And then the very end is on the first one because we haven't changed it yet. So I'm going to change it to green. And now we have our cross section set, and we'll see what it looks like. So it's a little rough, but it's not too bad. The handle's a little rounder, and then the slimmer middle part, and then the square end.
Yeah, that's awesome. Had you ever held a Hurley before this?
Well, I got one sitting over there. At the end of this thing, I'll go grab it and I'll show it. Yeah, I load the next file. So I kept tweaking the the different parameters in that modeling tab until I came up with the Hurley that I was pretty happy with. This is just the top half, but it kind of flowed together nicely. And, you know, my mind matched the shape that I thought it should be.
And I see this is only currently one half of the Hurley. Is that right?
Yep. Yeah, good point. So that's what I'll show. So then I can select this whole top half and I'll copy to the other side. So that makes it, this is the top. I can click this button to change to the bottom and it mirrors it. And if you look on your 3D model, you can see the top and the bottom half.
So in our job setup, was this originally selected as a two-sided part?
Yep, exactly. Should have mentioned that. Okay, I'll close all of the next one. So the first one I was working on was for my father-in-law. His name's PJ, and I wanted to bring his name into the bottom of the Hurley here. So I brought his name after I found a Irish font that I liked, and I kind of flared it to match the shape a little bit. I thought that worked pretty good. And then I also wanted to bring in a Celtic knot at the top of it, just to give a little more flair to it. And to make this three-dimensional, see, the thing I really wanted to do was have it be raised up. I thought it'd be pretty easy to carve into the Hurley to make his name.
Right.
But more of a challenge would have it be raised up. And I think that'd be a little more rare to see.
Right. It's so easy to just V-carve the recess, but to make it, you know, elevated, it's super nice. But you also have to consider your tooling when you're programming something like this. You know, you want to make sure you have a router bit that can get in all those details. Yeah,
it's pretty intricate and detailed, isn't it? Yeah, I used a small 1/8" ball nose round bit to do the finishing pass. To make the letters raised, I selected his name. And in the modeling tab, I created a shape. And when I'm working on this, I'm constantly changing all the settings, trying to get the right, you know, trying to get it exactly like I'm thinking. But I think it's already set. So I hit apply. And then in the 3D model, you can see how it's raised up. And I love how it matches the shape underneath it. It just overlays it. And so where the Hurley drops off a little, the letters do the same.
Yeah, it turned out super well. I love that raised aesthetic.
Thanks. And then with the Celtic knot, I did create a shape along an extruded edge. Create a shape by extruding along one or more centerline edges. And this is another one where you need to have a cross section. So I clicked Use Selection, and then I chose my cross section right here that I made just for this. All right, so getting the toolpath set up for this, I extruded the outside edge of the Hurley outward, I think about 1/4 inch, and this will be the boundary that the machining happens within. And I also put some locating dowels around the Hurley, so when I flip the board over, I can put those same holes into the machine bed and tap some dowels into it, and it'll align the Hurley in the exact same spot for the underside machining. First machining I did is the holes, and then the second tool is our 3D roughing pass. And this takes material down to almost the shape of the Hurley. You can set a tolerance in there that'll stay away from the Hurley. I think I set it up to 0.04 inches. And then on the final pass, it gives you the actual shape of the Hurley. And it's just really tiny step overs. And this is what gives it the 3D shape.
Awesome. What do you have your step overs and everything set to?
So the 3D roughing, 0.05 machining allowance. Okay. And
yeah, I think under 1/16 of an inch is good. Sometimes I go as shallow as a 32nd for the machining allowance, depending on what your finishing tool is. So if you're using an 1/8 inch ball nose or 1/8 inch tapered ball nose, you might want to bring it down a little bit. But I think it seems like it worked out fine. Also, considering the density of the material that you're using is really important.
Like a softer wood might be more prone to chip, right? You'd want to give it a little more tolerance.
Yeah, definitely. Or the fact that the router bit can, cut through a soft wood much more easily than a hardwood like an oak or something like that.
Oh, that's true too. Yeah. Okay. And then on the 3D finishing pass, I did 10% step over of my 1/8 bit. So it was a long run on the machine cutting these things out. But I'll show you the preview here. I love the preview feature. It really helps me, since I'm still learning all this stuff, seeing what the machine's going to do. So I have both sides set up. The underside has its own tool paths, and so when you do the preview, it flips it over automatically and does that too. And another thing I did on the underside is put in some 3D tabs to hold the Hurley while it's finishing the machining. And so that's what it should look like if it comes off the table right.
Nice. Yeah, tabs are definitely an important strategic element in when you're machining a double-sided part, and considering those placement is definitely important.
I wish I'd put more tabs on here. Right. Like on the computer, you think, yeah, it's going to be nice and strong, and the fewer tabs, the better for having the more finished product. But I had a couple of them break on me. And once one or two break, it's just everything, you basically have to scrap the Hurley or whatever it is you're working on and start over. So I would have put more in if I did it again.
What I would say about it, it's not necessarily more tabs, but it is about strategic placement. I do think, so when you're looking at this piece of material in particular, my assumption is that your grain direction is going the length of the Hurley. Is that correct? Is left to right? So the tabs here are perpendicular to the grain, which means the grain is going left to right through the tab, which is really good for easy to remove tabs. So because the tab, if you hit it with the chisel or something like that, it'll just split on the grain. Whereas if you put tabs at the either end of your Hurley on the the tip of the end and then the head as well, then the grain is going through lengthwise and your tab is parallel to the grain. So that will make a much stronger tab.
Yeah, I never thought about that. That's a really good point. That with the grain, those small little tabs, they're going to snap off pretty easy, huh?
Right. Yeah. So if the number and the size and then the placement of the tabs are all the things you want to consider. I think here you made the good choice of making them rectangular tabs when you want to really make sure that your part isn't going anywhere and you don't mind a little bit of a hand cleanup later on. So I would say if you put the tabs on the tips, is this making sense? Do I make sense?
No, I totally get it. Okay. Yeah. The grain goes through the ends and that's where the tabs would be stronger. That makes a lot of sense.
Right. Exactly.
And actually it's pretty critical for like an actual Hurley that they use. They try to use the base of the tree and they match the grain to the shape of the Hurley. Like they put the bottom where it kind of flares out to match the bottom of the Hurley. I thought that was kind of cool.
Oh, that's interesting. Like how the grain spreads out towards the roots, like towards the base of the tree.
Yeah, you want the grain running along the middle of the Hurley and then at the end flare out to match the shape. Otherwise, the end would be really weak, like you're talking about, and break. So
right, because that'll have a short grain right there. Interesting.
Okay, let me load the next one up. Oh, and the last one is a little bit of video I put together of the machining.
Cool.
So it's one big piece of ash that I got. And another thing I messed up on was I tried to squeeze too much out of it. I just put the pieces too close together. See, I'm doing all four of them right there. And it just got really stressful towards the end and I had a couple of them break. So if I was doing it again, I just would have had a little more waste and a little more scrap and I think it would have been more secure. So I did my roughing pass and now I'm switching over to the ball nose. And it just looks like it's barely doing anything at all because the step over is so small. It was pretty fun to watch.
It's been a super long run, especially it being double-sided.
Yeah, it was hours. Corey, your fellow worker up there at Avid, gave me the idea to FaceTime myself. And so I'd set my phone up out there, FaceTime myself, and then I'd go in the house and watch the machine run.
Yeah, I call this the baby cam, you know, when you set up a camera watching your machine and then you can go about do other things.
That's a great idea. So that's the finished Hurley. I'll grab the Hurley, I'll show you. I guess you can't see it, but there's a Hurley. Turned out pretty good, and I put tape along the ends. And my father-in-law was pretty happy. Gotta keep him happy, you know?
Of course. What a nice gift. That's just extra special and
Thanks.
Custom, bespoke.
And it's something that I think really uses the abilities of a CNC table. I mean, that would be really hard to do without a CNC table.
Definitely.
Okay, next project. I think I'll do the sword.
This was a super fun project. I especially enjoyed the costumes that came with it.
Well, they'll have to watch the video on my YouTube channel if they want to see me in a dorky costume. So this is the sword that I got commissioned to make. A little ridiculous, a little overkill, but I thought it was going to be fun to work on and figure out how to do this with the tools I have at my disposal. So looking at it, I thought I would use 3/8 inch plate around the outside. That's going to make most of the sword. And that plate would continue up into the handle. And then the center part that's black with the engravings, I thought I'd use a hard plastic called UHMW. We have quite a bit of it on the farm here that we use, and I could grab a piece pretty easy. And then I was going to overlay some upper pieces to hide the seam between the metal and the UHMW and finish off with the decorations here. So just kind of the same thing. I started drawing around the outside of the blade to cut that from the CNC plasma table. I put a line right down the center, a guideline, that I can mirror everything over to the opposite side from. So I was only going to model one half of it. I started at the point and just started clicking around it roughly. I won't do all this, but I'll just show a couple of them here. And I switched the lines to Bezier curves.
Bezier.
And just keep manipulating the points until it matches the shape pretty closely. And then like this side here, I can just mirror to their side, so both sides are identical. And eventually I had the first piece I wanted to cut on the table drawn out here. When
so
I'm
this
doing
first part, you're cutting out of steel?
Yeah, this first part is going to be 3/8 inch plate, which is going to be crazy heavy, but I thought the thickness would I thought it would match this style of ridiculous sword here. So to cut things out with the CNC table, the plasma table, I select the vectors I want. I don't want the bitmap. In fact, I'll turn the bitmap off here. So I select the vectors I want, and then I export as a DXF. I save it somewhere in my computer, and then I import the DXF into SheetCam, which does the programming for the CNC plasma table. With CNC plasma, you always want the inside pieces to cut first, because if you cut the outside, then the piece can move pretty easily and your inside cuts wouldn't be accurate. So I made sure I'm cutting the first one on the inside, and then the next cut is on the outside. And I usually put the start points on corners if possible. Like this one works really well.
Interesting. I don't always put it on corners.
Really?
Yeah, well, why? Tell me about the strategy of this.
I think like this shows it's going to start here and lead into it. And then as it comes around, it's going to lead out. And that gives you like a nice point. And I feel like if I start somewhere on a straight edge where it leads into it, here I can move it. It leads up here. Where it leads into it, and then as it comes back around, there's going to be a little kerf, or like a part that's not quite as straight.
Right.
As long as the plasma is established and cutting, it leaves a really nice edge. But if it stops or moves, there's a little bit of a curve to clean up. So I usually like to do it on the corners.
This is why lead in, lead outs in plasma CNC in particular are super important, because it has to, when it does the initial pierce, it's going to leave a larger mark than as it's moving in a regular cut. One other thing I would love to point out is when it changes directions, you can have it do kind of like a loop-de-loop roller coaster, which is also another fillet option in V-carve as well.
Oh, so like if you're doing a sharp corner, it'll loop around?
Yes, yeah. So they have a plasma CNC or drag knife loop that you can program in V-carve, but you can also do that here in SheetCam too, in the CAM aspect rather than in the CAD.
That's pretty cool. And that just gives you a little nicer corner?
Yeah, it does, because then the machine doesn't have to slow down to change corners or to change directions. So it just kind of does a loop around each corner.
And that's where you need to have your anti-dive and everything set up right, so it doesn't dive when it meets up with its own path that's already cut, right?
Right. It's a small enough gap that if it's already moving, it shouldn't be too much of an issue.
Just jumps right across it. Cool. So I got the 3/8 inch plate loaded up on the plasma table, and I'm gonna cut out the sword.
Gosh, this is so fun. I love it. I love blending plasma CNC elements with router elements and kind of bringing them together to make something really complex and layered, and especially for a fun project like this.
One thing I do with the CNC plasma on the sticker stuff is after the initial pierce, I always knock the splatter off, because there's a little bit more splatter that can knock the tip off when it comes back around. So that's what I'm doing with the hammer right there, is it just easily chips away and you don't have to worry about it.
So if anybody hasn't used plasma CNC before, I'll tell you it's very satisfying. It is a definitely different type of experience than using a router, because I feel like there's a lot less to worry about in terms of work holding, and there's sparks and instant satisfaction and fire. It's so much fun. So definitely, if you have an opportunity to explore or play with plasma CNC, I really encourage it.
I started off with plasma. I didn't get the router table until a couple years later, just because I do a lot of welding and metal work on the farm. And man, I just use it all the time for cutting brackets and fixing things. And once you start using it, you just get more and more ideas of how you can use it. And I love it. It's great. And yeah, like you said, you don't have to worry about the work holding. You just set it on there and it stays put. It's pretty amazing.
Right. You don't have tabs. You don't have to worry about all of that. Also, your water table looks very clean.
That must have been some fresh water. It's not so clean right now. So the next piece I wanted to do was the UHMW insert. For this, I took the same line as I cut on the sword, and then for the engravings, this is another thing that took me a couple tries to get right. I thought I was just going to do some V-carves, where I'd do like a sliver that got a little wider in the middle and then tapered off, and there'd V-carve between it. But then I found the fluting tool. Have you ever used the fluting tool, Sammy?
Yeah, that's what I was going to suggest actually for this, but you're ahead of me, so go ahead.
It worked perfect. I drew one vector in the shape, kind of the swirlies, and then the fluting tool tapers. Let me see, I'll open it up here. So it used the V-bit, and you set a depth that you want it to go, and on the ends it tapers up and tapers down. And you can set it for a smooth taper or linear taper, and it just worked perfect for this engraving here. I'll do a little preview of this and see what it looks like. Let me do that a little bit slower. So
Awesome.
that'll look pretty cool.
Oh, Sparky.
Does your cat want to say anything?
Yeah, Sparky, come here.
Does he like the floating tool?
Yeah, he loves it. Hold on. Let him out the other door. I'm like a full-time door attendant for the cat now that I'm home all the time.
So then this is a video of the UHMW that I got clamped down on the table. And this is the fluting tool. The UHMW is 1 inch thick. And so I needed to mill down the underside to match the thickness of the sword, which is 3/8. The top side I just did the fluting on it, and then I flipped it and milled it down to the thickness and did the fluting again into that.
How well did this machine? It looks like it machined pretty well.
Yeah, it did pretty good. There's kind of burrs along the edge that I had to go in and scrape off with a knife. And this step left grooves in it that I had to sand down a little bit. Mm-hmm. After some cleanup, it worked really good though. Oh, that's loud.
So what kind of router bit do you use for this step?
That was just a 1/4 inch end mill. Mm-hmm. Think that's would be the best?
Well, I'm just saying, I think that upcut is typically really good for plastics because it's lifting the chips up and out rather than putting a downward pressure, creating more heat.
Oh, okay.
So acrylics and plastic definitely benefit from keeping it cooler.
That is something I definitely had trouble with, was it getting hot, and it gets harder to cut, I think, when it gets hot, a little softer and gooier.
Right. Oh, look at that fit.
It was so satisfying just tapping that thing in there. It's great. So now that I had the UHMW milled, I wanted to cut the other top pieces here. And I designed this so the next piece would overlay the seam between the UHMW and the metal, kind of hide the seam and also sandwich the UHMW in place. I could weld the metal upper piece onto the lower piece with some plug welds, and it should all hold itself together in theory. So I drew all those shapes, got it here, and then I laid out all the pieces so I could cut it on the plasma table. It works pretty good for me to take the pieces and lay it out in a spire. Like an efficient way to cut it versus doing it in sheet cam later. It's just kind of how I choose to do it. And then I export this DXF and load it into sheet cam and cut it on the table. So I think the last thing we
Definitely nesting in sheet cam is not as possible as it's not as easy as it is in VCarve.
I have trouble doing it. I'm sure everything's possible that I want to do, but it's not quite as intuitive for me. It's easier for me just to keep everything on one file, one DXF file that I can load into sheet cam. And the last thing is a little bit of video of the finished product. It was heavy. It was like 40 pounds. So it's...
I know. It's like, I know you shouldn't have too much difficulty lifting things up, but it looks so heavy to carry. Just kind of awkward because of the balance. And
I grabbed some more Hurley tape to wrap around this handle.
The finishes are so awesome. I love the patina that you used.
Thanks. Yeah, I do that a lot with the metal, and I like that look a lot. And then I wanted to keep the blade shiny, so I just kept that separate.
Well, I think something really interesting to take from this project for anyone else who's working on something with mixed mediums is to look at the different types of finishes and textures that JD brought to this project through the plastic kind of glossy surface with the rustic details and then a kind of shiny beveled edge. So considering that that variety makes your project far more interesting.
Thanks. Yeah, I like doing wood and metal a lot too. Having both the plasma and the CNC router is just a fun combo combining the two and starting an Aspire and then creating both the metal files and the wood files, and they usually fit together pretty nicely if you get everything right. So it's fun mixing the two mediums, like you said. Okay, so the third project that I want to cover is the 60-inch bowl. And like I said, this was just a dumb project. I started thinking about how I would make a big dome from plywood. And then I thought that if I'm making a dome, I might as well make a bowl. And then once I started figuring out how I thought I could do it in Aspire, I was like, okay, I might as well just go ahead and make it. And so this really started out just wanting to learn some 3D modeling in Aspire. And then once you get that on the computer, you gotta go out there and make it after that. So my routing table is 60 inches wide, and I thought I'd just use all of it, minus minus 1 inch on either side. So not at the very extreme, but came in just a little bit. And this between these two guides is 58 inches, and then the z-axis is 8 inches tall, and that's what this guide here is. And then I created an arc between those two points and brought it up, and that's the rough shape of the underside of the bowl. Next, I used the offset feature to bring this shape in 3/4 of an inch. Which will be the thickness of the bowl. Yeah, I always get that backwards. Like, you'd think this would be inwards, but I actually had to move it outwards to get it to come in.
Right. When it's an open vector, it seems to kind of alternate for me. Sometimes I get it right and sometimes I don't.
It probably has to
so
guess.
Sometimes I'll just do both and then delete the one I don't want.
Yeah. So I'll open the next file. This project was probably the most time intensive in Aspire for me because I was really learning a lot of the stuff as I went. And so here's the shape of my bowl. I gave it a little base to sit on, and then gave it a lip at the top and kind of flared the top of the bowl inwards a little bit so it's more like a bowl. So I'm making this out of sheets of plywood. And the challenge for me was to figure out the size of rings I needed to match the shape. And to do that, I used guides as a thickness to match the plywood. I was using 3/4 inch pieces of plywood. So I set up a bunch of guides to match that. Guide, crank this up. So each of these layers is one layer of plywood. And then I thought for machining, I would give myself a 1/16 margin for error. So I offset the bowl outwards 1/16.
I love that you can type fractions.
Yeah, I do it all the time because I don't have the decimals memorized. And so then I could see that at the bottom left corner here and the top right corner of the outside is where the ring needs to be to fit the shape of the bowl inside it. Does that make sense?
Mm-hmm.
And I just started drawing rectangles to match this.
I think having that 1/16 offset is really important, especially when you're going to glue up rings like this. The rings can slide around when you have your glue adhered if you don't have alignment pins or something like that. But if I do recall, you made some excellent jigs to help with this project, which I think was definitely my favorite part of this project, aside from the fact that it was just an amazing, silly thing, and I cannot wait to make a salad out of it.
Yeah, so at first I thought I was just going to put a little mark on each ring to mark where the next ring went. But then I started thinking that if like one at the bottom is off a little bit, then all the subsequent rings are going to be off too. And I realized that I'd better make a jig to make sure all the rings are lined up.
I know I use the jigs that you made for this project as an example in a work holding talk that I gave, because I just love the custom jig making to help make your project process easier. You know, it's not too much more additional time considering how much time it saves you.
And it's so much more accurate. And it's like what I was saying in the plasma cutting, like once you start using it, then you have all these other ideas of how you can use it in other ways. And this was just another example of that with the jigs. Like you're like, oh, I can just make this perfect jig that everything will lock into place, and it takes the guesswork out of it.
Right.
So here's all my cross-section rings. And to make the jig, I connected the bottom across and then started using the scissor tool to eliminate the rings. I have the finished thing here. I'll load that up. So there's all my cross-section rings. And then I have, if I turn that off, you'll see the jig underneath it that'll lock the rings in place.
That's awesome. Did you put dog bones on this?
Yeah, I did. Yep, because let me load that up again. It's a good point. This isn't the finished one that I machined. Mm-hmm. But the one I actually cut, I put a dog bone fillet at each corner so the ring can sit all the way down. Because the round tool bit would actually leave a little radius on each corner, and it wouldn't let it sit all the way down. So I did do that.
Right.
Yep.
Can you bring the dog bone or the fillet option up?
I use this tool all the time. I love it.
It's awesome. So that, you know, either if you do a normal fillet, it gives you a realistic expectation of what that corner will look like, or if you use a dog bone fillet, which is perfect for this application. And below T-bone fillet is plasma and drag knife fillet, which I just wanted to point out is there if you are going to do plasma cutting. But then if you do that, make sure you do accommodate for the kerf of your torch.
So just a regular fillet rounds it over, which I use all the time tool for other things. But then the dog bone fillet, I think should go the other way. Yeah, so the 90-degree corner of the material can still fit on the inside, but this gives you enough of a radius for your bit to clear that area out. And this works good because I still have the upper part of the edge to lock the ring in place, and I still have the base. So it doesn't really matter that there's nothing holding this corner on the inside here. Mm-hmm. So then here's a little video of the jig. Made two sides that kind of locked into place. And I put holes in the bottom of it that I could use to clamp the jig down. I was going to use this both for gluing and for machining the outside of the bowl. So I needed to be able to hold it down. And see, there's my original ring around the rings that I thought would help align. But then as I started doing it, I was like, I just don't think that's going to be accurate enough.
But do you think the visual, it was helpful for at least laying the glue down?
Yeah, exactly. It told me where I needed to glue and helped a lot for that. That's kind of a thing that I didn't plan on, but it was helpful. And so it's kind of exciting for me knowing that the shape of the bowl is somewhere in that mess of a shape right there. And if I did everything right, that it was all going to come out. And then so I locked everything down. And actually the very top ring, I put a center mark on when I cut it out. So then I could zero on it and started machining the bowl.
And you got to push your CNC to the farthest lengths. I love it. That's what I loved about this project, because you can just see the gantry is just right above there. I remember maybe you had to move a bolt or something, but it worked out really well.
It's cool seeing the rings of the plywood start to show up as I cut it. One thing I didn't show was how I made the bowl. I think I kind of skipped a step there. So I have the shape of my bowl here, and for the modeling I wanted to do the radial sweep. And to do that you only need the right half of it because it spins it around the leftmost point. So I get rid of I made another copy of it with just the right half and the top part of the bowl. So just that shape's left, and then I can select it and do a radial spin around the left end point. And that matches this shape. See, this is kind of weird because this is two different views. it's the cross section, and then it's also the top-down 3D view of the bowl. So you have to kind of keep that in mind when you're working in it. But then the 3D view shows you the shape of the bowl here.
I definitely like having both 2D and 3D views open so that you can kind of understand more complex layer of what is you're actually doing when you're changing options in your selections.
It really helps to visualize it a lot better, huh?
Mm-hmm.
And then the toolpaths I did was a roughing pass and a 3D finish pass. One thing I had trouble with on the bowl was I wanted to do a roughing pass to remove as much as I could, but it's not machining it from a solid block of wood. Like there's no point in starting way at the top and working down, which I think is what the roughing pass is set up to do. So I actually kind of tricked the program a little bit. I did a 3D finishing pass, and I set it to an oversized bit. I set it to a 1/2 inch bit when I was actually only using a 1/4. And I also offset the Z-axis a little. So that means it's doing a 3D finishing pass, but it keeps it away from the final product a little bit. Does that make sense?
Yeah, clever. I lie to the CNC all the time. You know, sometimes you just have little workarounds for that kind of thing. And when the toolpath, there's one toolpath that is named something, but is closer to what you want to do in terms of roughing. You can use a finishing pass for roughing if you just change the settings to accommodate those needs that you need.
Do you feel bad when you trick your CNC table?
No, it's okay. It's just a white lie. She's okay.
I get a little thrill out of doing that stuff. It's almost like you're hacking it a little bit to get what you want. And every time it works, it's just, I get excited, you know?
I guess what I feel like is it makes me feel like a more advanced technician because I can really wrap my head around the approach that I need to take in order to get to where I want to go. And that is a really powerful thing, is when you get to a point where you realize you are the one who is controlling the machine. You know, you don't have to necessarily follow these specific steps that are laid out for you. And I think that's a really exciting thing when you get to a point where you can control all those factors and all those elements. I think it's a pretty exciting and pretty fun. It's thrilling, you could say.
I think it's because like you know how things are working and you're not at the mercy of the machine. The machine's at the mercy of you now. Like you can really control it to do what you want.
Yeah. Yeah, definitely.
So to do the inside of the bowl, I kind of had to do the same process to make a jig that it would sit down into. And this jig was going to have two purposes. It'd be one to hold the bowl in place and support it while it's machining. And also I wanted to make the jig a little bit oversized so that when I do a finishing pass on the machine, finishing pass on the jig, it'll give me a 0-0. Does that make sense? I don't know if that made sense.
No, it's okay. Sorry.
So I made the
Wait,
jig
it'll give you a 0-0?
just a little bit bigger than it needed to be. And I locked it down on the table. And then I did a finishing pass into the jig. Because I didn't know how I was going to precisely locate the jig. So I centered on the jig, knowing it's not going to be perfect. But then when I machine it, that 0-0 point is going to be perfect.
And I see. So you're zeroing to the jig for your bowl machining.
Yep. And then when I slide...
Right, rather than zeroing off of the bowl, because the bowl at this point doesn't really have any good reference surfaces.
Exactly. Yeah. And then I kept that 0-0 point. I slid the bowl into the jig and it just really locked into place. And I knew that the 0-0 was going to be perfect again.
Nice.
So on this one, I flipped the bowl right side up. And I made another jig to match the underside of the shape. And this circle on the inside here is the inside of the bottom of the bowl. So it'll slip down into that, and then this support over here will hold it. And then I also programmed the toolpath to run within this area because the jig's going to have 4 sides to it. And so it's not machining everything, like all the empty space. It's only machining the plywood. I think I have the, yeah, these are all the parts here. And these are all the parts to my jig. I did some more dog bone fillets and some tabs so everything will click into place.
Nice.
So here's the jig, and I'm gluing in the tabs. And see, this is where I set the boundary to be a little bit wider than plywood, and it's only going to machine the area it needs to. It's not doing all the empty space in between. And then it travels up each side.
Oh, I see. You're machining the jig to fit perfectly to the curve of the bowl.
Uh-huh. And so I established the 0, 0 to do this jig. And then when I put the bowl in, I kept that 0, 0.
Right.
And it was pretty satisfying how it clicked into place. And I put some double-sided tape on all the pieces of wood to hold it a little bit more. But the bowl was heavy enough and tight enough that it really held it pretty well.
Awesome.
I kind of wish I'd done a couple more supports. I think if I did this again, I'd do 8 instead of 4, because the area in between the supports was a little flexible, not supported well enough. And another thing I might do is do the inside of the bowl first, because it's a little weaker, I think, on the inside. Right. And then when you flip it over, the dome shape makes it strong. So I'd do the outside second.
Oh, that makes a lot of sense. Order of operations is really important when you're doing something like this.
Exactly. So then just a couple more here. The inside machining. This is the same thing where you take the right half of the machine. Sorry, you take the right half of the bowl you want to machine. And I'll get rid of the bowl shape here. And I sweep this around it. And it's raised up here because you want the thickness of the bowl still. If the point was down to 0, 0, then you'll start machining from the machine bed. And there's the dome of the bowl. And this is the same thing where I did a roughing pass. I did a fake roughing pass with the 3D finishing pass to remove as much of the material as I could, and then came in with the round ball nose to smooth it up. You got a little video of that here. So actually in the middle, I started with the 3D finishing, and it just was making it work way too hard. So I stopped and switched to the 3D roughing here, where it's taking out big chunks of the rings. And you can still see the grooves because it's not actually down to the final depth. And then I switched over to the 3D finishing pass. And this is pretty fun to watch. Just, again, looks like it's taking off very little, but it's what it needs to.
This is awesome. It's funny, this bowl makes the machine look small almost. This is a 5x10 machine.
It's a benchtop one. And on the very last couple of passes, the last part, it started chattering on me around the outside, and that's why I was saying, like, I'd probably do a couple more supports if I did it again. That's the giant bowl that I have no idea what to do with now. It's sitting in the loft of my barn out there.
Drake's new bed, one of his many beds.
And there's Kelly and I using it as a salad bowl.
You got to get it through the doorway without dropping the salad.
So we had to fake it for the video because we were in the kitchen when we made it. And then to bring it through the doorway, we had to go around through the hallway. So we faked it in the video. It looked like we went through there.
Awesome.
All right, so that's 3 of the more intensive Aspire projects that I've done. And yeah, just for all my design work and toolpathing, I use Aspire, and I've really grown to like it a lot. It's pretty amazing software. I think the thing I really like about it is that it's just really specific for CNC work. I know a lot of the stuff you could do in other programs like Illustrator, but there's just so much other things you can do in those programs that clutter it and for me, make it less useful. So I use Aspire, and I like it. Now I sound like a salesperson for Aspire. But
well, I think I love that you can just authentically use it for all of the projects that you do, whether it's really fun projects like the Hurley and the sword and the bowl. But I encourage you all to go check out JD's channel, because JD, your channel is one of my favorites because of the diversity of the type of content that you make, where some of it's really practical for a farmer's life, I'm sure, where you're making giant doors for a tractor or something like that.
Mm-hmm.
Like, I know all of the farm equipment names, but the spectrum of it and how you leverage VCarve and Aspire and the CNC machines to help you in different aspects of your making career, whether it's for fun or for work or to help fix things around the farm or the house. I think that you leverage CNC in a way that I aspire to.
Well, thanks so much, Sami.
But
there you go. Yeah. Thanks so much, Sami.
I didn't even plan that. So
yeah, the full videos of all these projects are on my YouTube channel if you want to check them out. And Sami, you've been doing some great stuff on Avid's channel too. Why don't you give Avid a nice big plug here?
Yeah, so Corey and I have 2 talks this weekend. One is about how to optimize your toolpaths for plywood and acrylics, and another one is for brass and aluminum. So I hope you all can come by and watch those and join us as well for learning how to really optimize and dial in your toolpaths. We've been doing live streams on our channel every Friday. That is in Pacific time. So I hope you can come by and check it out. We like to have really good, fun conversations about CNC and making things. And sometimes it's an interview, and sometimes it is learning how to dial in your settings for Aspire or for your CNC and your toolpaths. So we're here and excited to talk about those all those things that we love. Yeah,
both Aspire and Avid have great communities around them. And I think that's what sets them apart, and it's a lot of fun to be a part of. I was on the Avid's live stream a couple of weeks ago. That was a lot of fun. Mm-hmm. It's fun talking to you guys.
Yeah, it was a blast. Yeah, so come join us. We are so thrilled to be here at Vectric User Group, and thanks everyone for being here. We really appreciate you.
Yeah, we'll call that a video there. Thanks, Sami. Thanks so much for helping me out on this.
Of course. See you on the other side.
Bye.
I don't know what that is, what that means. Of course, I'm happy to be here.